In perception, we learned that the brain wants you to believe that it's perfect, and it's hard to prove it wrong. In memory, the brain also wants you to believe that it's perfect, but in memory it's easier to prove it wrong, because we forget things. This module is about memory and forgetting. First, some definitions of different kinds of memory, because research has shown us there are different kinds of memory. For example, first we have explicit memory. And these are the memories that you have consciously. You can take them out, you can work with them, you can put them back. Your conscious memories are called explicit. The name of your friends. What kind of car you drive? Explicit memories. Then we have implicit memories. And these are the memories that you don't have access to, but they influence your behavior anyway. For example, your prejudices. The big way of measuring an implicit memory is to judge how fast you respond on questions of morality or prejudice. Then it shows that you might have an implicit memory in that area affecting your behavior even though you don't realize it. Implicit memory also belongs to the area of procedural memory. For example, how do you ride a bike? You can usually do it without thinking about it because you've done it so often that it's become an implicit memory. You don't have to think about it in order to do it. Driving, stopping at a stop sign, assuming you stop at stop signs, it's an implicit memory. Yeah, you know who you are. And then we have semantic memory. The word semantic meaning the word word. Because research has shown us that we, after we acquire language, will remember things as words rather than pictures, because it's much more efficient that way. For example, if I tell you to remember that blue car, you will remember the word blue and you will remember the word car and piece together the pieces that go around it. But every time you remember something, you'll be reconstructing that memory instead of looking at the picture that you imagine. And the research shows us this because when we remember something from when we were 5 and we haven't remembered it since, we'll remember it in the language of a 5-year-old. But then, once we remember it, we'll record it because every time you remember something, you're actually remembering it again. So the next time you think of that thing you haven't thought of since you were 5, you'll remember it in the language that you speak now. And though that may be a confusing concept now, we'll go into it and make it clearer. We have flashbulb memory, which is, if your emotion is strong enough, you may actually remember something well enough to remember a lot of the little details. Now they won't be perfect, because eidetic memory is very rare. But because the amygdala and the hippocampus are so closely tied in that limbic system, and emotion is so closely tied to memory, the stronger the emotion, for the most part, until it gets to that point where it can't remember at all, the stronger the memory will be. We have episodic memory, which means you remember one thing based on the story that it fits into. When you went to Disney World, where did you park? Well, you may not remember that it was Goofy 3 until you start thinking, how did we find that car when we got out to the parking lot? Oh yeah, Goofy 3. It's part of a procedure, part of an episode, part of a story. In terms of remembering things, we have 2 major ways of doing it. The first is called recall, which is when you can think of something on the spot without any cues. That would be, for example, a fill-in-the-blank test. Or, what was that guy's name? You have to recall it without any clues. Then you have recognition, which is essentially a multiple choice test, where you have options to choose from. And one of those options probably makes you remember the thing that you're trying to remember. You get a cue. So recall, there's nothing to cue you into the thing, you just have to remember it. In recognition, you're given a major cue to remember it, and then you remember it. Now, recall is harder than recognition because it's harder to come up with something without any cues. It's easier to come up with something if you've got something to cue you into what you're looking for. And then you've got relearning, which is the second time you learn something, it should be a little bit easier than the first time. And this is why in education, mastery is considered 80% of 80%. If you can get 80% of the questions right 80% of the time, that's considered a pass. Because for the most part, they're not teaching you this stuff immediately. For example, in this class, you don't have to know this stuff immediately. What I want to know is, can you learn it again later easier? And we've decided that if you can hit 80% of the questions right 80% of the time, you're likely enough that next time you learn it, it will be a lot easier. Some keys to memory. Some of us don't have the best memory, so we need little strategies for remembering things. The first of these strategies is emotion. Because if we're totally bored, we're probably not going to remember things as well as we would if we got a little bit of emotion going on. A little bit of anxiety is good for memory. A lot of anxiety can shut us down. So we don't want too much anxiety, too much emotion, but a medium amount of emotion to keep us interested, not bored, but not overwhelmed, is good for memory. So, if we can play a game with content, we can probably remember it faster because we have something to relate it to and there's a little bit of emotional charge. Getting that amygdala and the hippocampus to work together to put memories down. If you need to remember something, it helps to make something a little bit more dangerous. Do you remember your first kiss? If so, was your heart beating really fast at the time? Was there something emotional going on? Is it a strong memory? Maybe not. Probably is. A second cue to memory is to self-reference, to somehow make that information important to you. Relate it to your life in some way. A third way is to elaborate a memory. Because in memory, it's not just a road where we have little lines that go up to each little memory. What it is, it works as a network. And every time you remember something from a different direction, that creates another road to get to that memory point. So if you elaborate on the material, you can tell a story like, oh yeah, this happened to me 20 years ago, this happened to me when I was a little baby, or this, hey, I see that in my parents, kind of thing. Then you're making an elaboration, and you can get to that information through different channels that instead of just going through the ones that says it was in the book. The more ways you learn something, the better it'll stick. More paths to get there. The more different ways you hear it, more paths to get there. And if you get Alzheimer's, and it starts to destroy those paths, the things we remember best are from long ago because we have different ways of getting to that information. The stuff we learned just recently, there's probably only one, maybe two ways to get that information, and it gets lost faster. A big reason why Alzheimer's patients tend to remember things from a long time ago when they can't remember things just recently. Context. Memory is context dependent. For example, if you could study in the same room where you take a test, and you've got all those little cues to cue you into what those answers would be when you were first studying it, you'll do better on that test. So, study in the same place where you have to take the test. And that should help a lot. Getting your brain activated somehow while you're studying helps. If you can chew gum, the flavor will actually activate the brain, give you a little bit of an emotional charge, even though you may not notice it, and you'll remember things better. The thing is, you want to chew that same kind of gum when you're taking the test to make that same association in that memory. The closer you can make your studying environment to your test environment, research shows us, the better you'll do on that test. It's also state dependent. If you can have the same emotional charge during studying that you can do during the test, that should also help. Because it's another thing to cue you in as to what you were thinking when you were studying. What you were feeling when you were studying. Another cue to memory is to overlearn it. For example, on that one, for the longest time before we had language, people would just put stuff into song, and they would sing it over and over and over again to learn it. The Odyssey from Homer. He didn't write that. He got that from a song that had been sung for hundreds of years. Probably hundreds of years. Because that was the best way people back then had of remembering things, is to learn it over and over and over again until it stuck. But mnemonic devices work. For example, please excuse my dear Aunt Sally. I hope you remember this one. It's mathematical sequence. Now, in overlearning and singing also, the more you repeat something or rehearse it, the better it will stick into memory. The more you use something, the better that memory will be. Because there's this thing called long-term potentiation, which means the more often you access that memory, the better the connections get to that memory section, where that memory is. So if I have to remember my phone number every day, I'm probably going to remember it better than if I only had to remember it once and it's on my phone somewhere. Then they ask me, what's your phone number? I'm like, I don't know, I never call myself. Okay, now the memory flow chart. See, what we've got out there in that big wide world is a whole bunch of stimuli. And that stimuli gets collected by our sensory organs and our sensory memory. Our eyes, our ears, our nose, touch. A lot of sensory organs picking up information. Now, each one of these sensory organs is a little bit different. Each of these sensory organs pick up stimuli and keep it in different ways. For example, the eyes. Visual memory. It's called iconic memory. An iconic memory can stay in the eye sensory organs for about a 20th of a second. Now that's important because that gives us persistence of vision, which means film, when it's being run, and film is usually run at 24 frames per second, it can do that without us seeing the flash, 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 flash. So as long as you can flash frames faster than that, you should be able to get an automatic picture, a motion picture. And in some circumstances, you can actually get that down to a quarter of a second before you start seeing frames. Auditory memory, called echoic memory, you've got longer. You've got between 4 and 15 seconds with echoic memory. An example of this would be, have you ever not been listening to someone and they've been talking, and then after a while they look at you and say, what did I just say? And you can remember what they just said to about 10 seconds ago? It's because we need 10 seconds, 14 seconds of memory in our ears so that we can remember what they're talking about when their sentence started by the time they get to the end of the sentence. And sentences that last for more than 10, 14 seconds, we may forget what the subject's about before the sentence ends. So be aware, if you have a long-winded professor, the sentence should only last about 10 seconds before I start losing you. So then, the sensory organs send this information through the brainstem where it gets filtered out for what the brain determines is or isn't important. And the result of that filtering is what we call attention. Because we've got all these big, massive stimuli out there, but in order to get into our memory, it has to go through this little bottleneck where only a certain amount of information can actually get through. Attention. Big stimulus is out there, very small attention net. But for the information that does make it through the attention filter, it goes into short-term memory, which can last 30 seconds or so. The thing about short-term memory, according to the research by Miller, is that we can only remember, on average, 7 things, plus or minus 2. So the average number of things we can remember, single units, is going to be somewhere between 5 and 9 units as adults. Children have a range of about 3 to 5, depending on how old they are. So, in adults, 7 plus or minus 2 is considered a magic number. Because if we have telephone numbers that are longer than 9 digits, gonna forget some. So, when we do have to remember digits that are longer, there's 2 major ways we can remember it. We can either rehearse it, saying it over and over and over again, hoping we don't just forget one of those numbers in the middle. Or, let's take this random number for example. 1, 7, 7, 6, 1, 8, 1, 2. Oh, how about 1, 8, 6, 5, 1, 9, 1, 8, 1, 9, 4, 2. Big long number. How do you think you can remember it? Well, there's some things that we have learned through research. For example, if you can remember best the things at the beginning of a number, that's called primacy. We also have a tendency to remember best the things at the end of the number, that's called recency. But it's those numbers in the middle that tend to get lost. Also, according to a researcher a long time ago named Ebbinghaus, we tend to forget half, if not 3/4 of these numbers almost immediately. And it's usually going to be the numbers in the middle. However, if rehearsal won't work, because that's a really big number to say over and over again, what we can do is called chunking. So if I put a dot here, and here, and here, and here, then we're dividing this up so it's no longer so many different numbers. It's actually now just 5 numbers. Now, if we can elaborate and self-reference, if we can make these numbers important somehow, that'll make them easier to remember. Looking at these numbers, is there anything you can see that might make them important? Well, they do kind of look like years, don't they? Right. So, is there anything important about these years? Well, those numbers are the years of major United States wars. The War of Independence, the War of 1812, Civil War, World War I, World War II. Remembering that should make this whole string of numbers pretty easy to remember in the future. Maybe forever. You might be 80 years old and remember these set of numbers. So, once that information is in short-term memory, we can work with it. And when we work with it, then it's essentially called working memory. And what we do with working memory is we toss it around, we change it around, we add those numbers in a math problem, or subtract them, or multiply them, or divide them. That's all working memory. And as long as there's not 7 numbers we have to remember, plus or minus 2, we should be able to do that problem just fine. More than that, you probably want to write it down. Then, if we remember it well enough, we put it into long-term memory. And the word for this is encoding. We're encoding that information into long-term memory. Because research on the brain happened about the very beginning of computer research as well. So a lot of the terms are going to be interchangeable. So when we encode things into long-term memory, they are essentially there forever. Now we may lose track of where they are, but that memory is theoretically still there. And it may take a lot of jarring to get it back. But as long as memory gets through attention, then it should be in working memory and through to long-term memory if it lasts that long. To bring it out of long-term memory, that's called retrieval. And that goes back into working memory, where it gets manipulated again and then sent back into long-term memory as encoding. In kind of a circle. And every time you remember something, you'll encode it again as a brand new memory. Now, what we mean by volatile in terms of memory is that we forget things really quickly. So, sensory memory is going to be very volatile because depending on which organ you're talking about, you've only got from 1/4 of a second to 15 seconds before it's just gone. And if it hasn't made it to the next step in that 1/4 of a second to 15 seconds, you're never going to get that information back. And then, short-term memory, if you've got too many things in there, you're going to start losing them. Short-term memory is like what you hold in your hands. Long-term memory is what you have on the desk. Things can sit in long-term memory forever, but they can't sit in your hands in short-term memory for very long because you've always got something else to pick up. So you've got to set it down on the desk, and if it falls out of your hand before it gets to the desk, if it falls out of your short-term memory before it gets to your long-term memory, there's no way to go down and pick it up. It's gone. You have to wait for another stimulus to come through. So the hard part is getting it to long-term memory. But once it's in long-term memory, it's usually pretty good. So long-term memory is not considered volatile. Long-term memory doesn't have as much decay to it. Whereas short-term memory and working memory, there's a lot of decay, which means you lose it. Now, one aspect of memory that's very important is when you recall, you're most likely going to retrieve a prototype. For example, if I say, remember a lion. Okay, well you're probably going to picture a big lion with a huge mane. You're not going to picture a little scrawny lion with mange and hair falling out, because that's not the typical lion that you would imagine. It's possible you could remember Simba, but you're probably going to remember Mufasa. Because Mufasa, the king of the lions, is the prototype lion. It's the most salient, and salient is a definition for what gets your attention the most. If you've got a string of lions, and they go yellow, 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 purple, yellow, 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 that purple lion is going to be salient because it gets your attention fastest. You're going to say, what's that purple lion doing there? That doesn't make any sense. It doesn't fit the prototype. Because when you think of lions, not only are you thinking of the prototype, you're making that prototype into a stereotype, most likely. And that purple lion doesn't fit the stereotype, which is the danger of stereotyping, because it doesn't fit every situation. What that's called is a heuristic. And a heuristic is a big, ugly word for a mental shortcut. And we take these mental shortcuts because our brains actually work very slowly when compared to how quickly social society works. Our brains actually move quite slowly. So we need to keep up. And how we keep up is by taking mental shortcuts. Like stereotyping. If I say the word cowboy, you get a picture of a cowboy, probably wearing a hat, right? Not all cowboys wore hats. But it's easy to make that stereotype because it's a shortcut. You don't have to ask me, well, was he wearing a hat? Now, there's an error in that, which is the problem with stereotypes, and something we need to be aware of. Now, another one of these shortcuts is something we use in procedural memory. And procedural memory being kind of like episodic memory, whereas you have this expected procedure of things, and that's how you remember them. And actually, you probably won't remember them unless something happens that takes you out of that procedure. For example, going to a restaurant, a sit-down restaurant. What's your first step? Well, probably something along the lines of figure out where you're going to eat. Then you have to actually go to the restaurant. Then you get seated, and they ask you for drinks, and then you order your food. No, you get your menus. See, I missed one. You get your menu, then you order your food. Then you wait. Then you get your food, then you eat. Then you leave and you go home. Oh, no, wait. You pay your bill, then you leave and you go home. Because if you miss any one of those, you're going to notice, wait, that's wrong. And the procedure in creating these memories, this shortcut, is called a schema. They're patterns in long-term memories to help facilitate memory or make memory work faster, to organize the information. Now, because we use these heuristics, these shortcuts, we also make errors. For example, confirmation bias. We've heard this one a lot. This is the one where if you expect something to happen, you'll probably remember it as happening because it's just easier to remember what you expect to happen. Functional fixedness is another one of these. If you see a pencil, what's it for? Well, it's probably for writing. But could it also be a dart? Well, sure, if you think of it like that. And the availability heuristic, what you commonly think of, or what's salient. If you go gambling and you win, you're probably going to remember winning more than you lose. It's the problem with horoscopes. If it's right, you're going to remember the time that it's right, and you're just kind of going to forget the ones that weren't right. Even if it's only right 1 out of 30 times, you'll probably remember that gambling victory more than you'll remember all those times that you lost. Whatever has the most emotion is also likely to be the most remembered. So you automatically think that that happens more often than it does. Usually. Amnesias. Okay, there's 3 kinds of amnesia we need to know about. The first is infantile amnesia, and that's pretty much everyone goes through. Because when we're little babies, we don't remember things as words because we don't have language. We have to remember things as pictures. And the problem with that is it takes a lot of brain processing power to remember everything as a picture. Except for faces. We have a brain structure that's for remembering faces. So faces are going to be easier to remember. Even as adults, what's easier to remember? A face or a name? It's hard to put that name to that face, but we can remember faces because we have brain structures specifically for remembering faces. Infantile amnesia, I'll go back, is when we learn that language, we tend to forget everything that was before that. And the most common theory is, as we learn language, the brain reorganizes itself to remember things more easily as words, and it tends to forget all of the pictures that it used to know. For example, a 3-year-old can remember what happened when that 3-year-old was 2. But when that child turns 4, that child will not remember what happened when it was 2. It will forget just about everything. And sometimes those kids know they're going to forget, which is a little spooky. They can see it happening. They can say, like, I'm not going to remember this next year. I've seen that happen. That's freaky. They know they're not going to forget it. Second type of amnesia is called retrograde amnesia. And that's where you can't remember something that just happened. This is actually very, very common if someone who hits their head or falls down. Suddenly they can't remember for the last, I don't know, between 3 hours and 2 weeks. Oftentimes that memory will come back in a couple weeks. Sometimes it doesn't. Anterograde amnesia is when you can't remember things that just happened. This is more rare. This requires an actual damage to something, usually the amygdala or the hippocampus. If you lose your hippocampus, you can't create memories. That's a problem. So if someone gets their hippocampus damaged, either by a stroke or by some kind of damage from falling or head injury, car accident could do it, you can't place new memories. Which means you could go for 20 years just with the memories you had 20 years ago. So, if you've been filling out the guided notes, explicit memory refers to knowledge and experiences that can be consciously remembered. Episodic memory means those memories stored in the form of procedural experiences, personal experiences. Either one of those will work. Semantic memory consists of knowledge stored as words. Blank means retrieving an explicit memory to fill in a gap. That's recall. And blank means recognizing memory from previously learned. And that's recognition. Though you could also use relearning in that. Implicit memory refers to influences of experience on behavior, even if the individual is not consciously aware of those influences. Knowledge of what steps need to be taken to complete a task is called procedural memory. Hearing the word kindness an hour before volunteering to help someone with their homework may be an example of priming. And priming being, if I haven't covered it, putting someone into a mood to remember things before they actually need to remember it, or to influence their actions in the future. If you still see a video game, even when you close your eyes, this is an example of iconic memory. Where we work on memory in short-term memory is called working memory. Miller's experiments showed us that working memory consists of 7 plus or minus 2 chunks. Ebbinghaus showed us that most forgetting happens immediately. So yes, people will tell you not to cram, and it's not the best way to learn, but considering if you haven't overlearned it, you're probably going to forget things pretty quick. Which is why when you study for something and you cram for it, after you take the test, those memories are gone. Unless you have some way to relate them to yourself or some kind of emotional charge to go with it. Primacy means you are more likely to remember the first thing. Recency means you are more likely to remember the last thing. The most typical member of a category is called the prototype. And remembering the procedure for going out to dinner is called a schema. Shortcuts to remembering are called heuristics, but may lead to errors. And getting an H to help you remember that the last one is called a Q. C-U-E. That's why there's 3 lines there. Alright, that's the memory chapter. Woohoo. Yay. Remember that. 50 years from now, remember that. Ah, you'll remember. I hope you'll remember. Yeah, you'll remember.